The paper presentation will discuss post-glacial landslides. The research statement of my paper is the paper will investigate landslides in San Juan volcano field and the potential impacts of environmental change. The objectives of this paper is to examine the important factors in landslides and how they operate, to examine the important factors associated with landslides in the study area, and to examine the potential effects of environmental change on landslides in the San Juan volcano field located in Colorado. Overview of the geomorphic process. The geomorphic process that will be discussed in the poster paper specifically is landslides. In the article, A Chronology of Post-Glacial Landslides suggests that slight increases in precipitation could trigger a disproportionate geomorphic response by Johnson et al. Discusses several different types of landslides that occur in the study area. Some of these landslides include deep-seated landslides, as well as different types of slides and fields. Post-glacial landslides may occur due to bed slope, ice thickness, and temperature. A layer of meltwater on the bed of a warm glacier helps with the slide by loosening the surface flow, decreasing bed roughness, suppressing small inequalities, and if there is enough hydrostatic pressure, that is being used to assist the weight of the ice, according to Trent Hale in 2013. In the study area, large deep-seated landslides are a common occurrence, according to Johnson. Deep-seated continuous or mass rock creek landslides is driven only by gravity. It is a slow but large-scale movement of fractured bedrock along weakly defined surfaces below the depth, affected by daily and seasonal variations in moisture content. These movements are caused by stress produced by the weight of the material above. The upper part of the slopes, affected by mass rock creek, are distinguished by twin ridges, trenched and uphill facing scarps. Specifically, the lower and middle slopes are convex in shape due to rock bending, bulging, and folding. Slides. Slides are slope movements where material slips over one or more surfaces. Slides can occur on more gentle soil-covered slopes as a result of increases in water pressure during periods of heavy rain. Glaciation in quickly downcutting rivers provides appropriate steep slopes, typically displaying geological discontinuities, including bedding, cleavage, or driftwood. Dipping steeply upward. The difference between translational slides is they are usually straight or planar surfaces, while rotational slide slopes are along curved surfaces, according to Trent Hale in 2013. Flows. Flows are the movement of a true flow is close to a viscous flow. As velocity decreases with depth within flowing material, water is crucial for motion. Flows typically occur over an existing ground surface. Debris flows. Debris flows are caused by heavy seasonal rainfall or snowmelt, both of which activate glacial and glacial fluvial deposits and colluvium in valleys and on mountain slopes. Glacially prompted debris flows in mountainous regions can be caused by the quick draining of damped and ice marginal lakes, specifically when lake pressure is greater than the strength of an ice dam. Lakes dammed by glacial moraines and water pockets in and under the ice. Debris flows sometimes develop directly from bedrock mass movement. When water is added to the moving mass, typically occur when bedrock debris is blocking or constricting a river channel, is activating during periods of heavy rainfall or overflow. Several other factors may trigger debris flows. Vegetation holds sediment together and controls the runoff of water. Debris avalanches and debris flows may happen when vegetation is burnt or removed from urbanization or logging. Landslide triggers. The triggers of landslides are precipitation, temperature, slope stability, and seismic activity. In the study area, it appears that seasonal weather events are more likely to trigger a landslide instead of broader climate change. The southeastern San Juan Mountains often receive precipitation in the form of larger events from the North American monsoon. The deep-seated landslides in the study area are not commonly initiated by individual weather events. However, a wet season may be enough to alter groundwater pressure, which can cause a landslide. Slope stability is a condition that varies with time, especially in long-term landscapes affected by glaciation. As glacial cycles evolve, the factors influencing slope stability change. These factors include ice mass distribution, vegetation assemblages, in cover, hydrological conditions, glacial erosion, and size misleading. Therefore, the distributions, magnitudes, and frequency of slope failures change throughout glacial cycles. Landslides dominate erosion processes and overwhelm sediment distributions and mountains, so understanding the non-uniformity and unsteadiness of landslide activity is important for quaternary landscape evolution and sediment flux models, as well as for managing landslide hazard risks in glaciated areas, according to McColl in 2020. Landslides triggered by rainfall occur in most mountainous landscapes, such as a study area is a mountainous landscape. Some of these landslides occur suddenly and travel many kilometers at very high speed. They can pose grave threats to life and property. Other landslides respond slowly to rainfall and move at imperceptible speed, but they can dominate sediment yields and landscapes change for years or even millennia. Traditionally, prediction of rainfall-triggered landslides has relied mostly on recognition of landslide-formed terrain and identification of rainfall intensities and variations that cause slopes to fit, according to Iverson and 2000. Precipitation and climate. According to Mateo and Daniels, their article, Surface Hydrological Processes of Rock Glaciated Basins in the San Juan Mountains in Colorado. In Colorado, the climate has become too warm to sustain large ice glaciers at elevation. This can lead to slope instability as large ice glaciers underneath the land surface are melting. In the study area, in Colorado specifically, the glaciers that are found underneath the surface are specifically rock glaciers, according to Mateo and Daniels 2018. Rock glaciers contain substantial water stores in arid and semi-arid regions in San Juan Mountains of Colorado, respectively. Depending on the season and the direction the basin is facing may change the amount of discharge of each basin. The temperature difference and timing of solar radiation may impact the daily and seasonal quantities of discharge on each basin. According to Mateo and Daniels, the San Juan Mountain experienced significant annual and diurnal variation in temperature and precipitation. This variable climate of the San Juan Mountain is largely controlled by elevation and topography. The mountain range typically experiences warm, moist air from the south that undergoes orographic lift and develops storm systems that precipitate at the higher elevations of the mountain range. Intrusions of moist air are most common during late summer months and are associated with the wind pattern known as the southwest monsoon. Southwestern United States is typically warm and arid. This area is known for having low precipitation, clear skies, and warm temperatures year-round, according to Mateo and Daniels. Daily precipitation varied over the months of October and did not follow any specific pattern, according to Mateo and Daniels. Precipitation did contribute to a couple of runoff events in each basin observed in studies discussed in Mateo and Daniels' article. And extended dry periods happened in the summer months. According to the article by Johnson, the West Lost Creek landslide occurred in 1991 and has characteristics of terraced swamps, rock flows, and rotational blocking. The slide is thought to have been caused by higher than average rainfall in the previous 12 months. When discussing precipitation in the study area, is typically known for having low precipitation. However, precipitation has been increasing in the study area. This could be due to climate change, however, it has not been proven. Study area. The study area that will be discussed in my paper is the San Juan volcano field in Colorado. Landslides in the study area occur mostly in higher relief areas. They were usually below the regional equilibrium plant altitudes. The topographic division of the study area has large ice caps in the southeastern and western San Juan Mountains, and smaller valley glaciers in the intervening area. The relatively flat-lying volcanic stratigraphy in the San Juan Mountains resulted in several ridgetops being eroded flat to the San Juan ice cap and are separated by deep glaciated valleys formed by valley glaciers before and after peak extent of the ice cap, according to Johnson AM. Overall, the relatively soft nature of the bedrock almost certainly plays a role in the initiation of landslides, and yet the variability of the bedrock, both in the units and between the units, makes it difficult to identify clear trends between bedrock types and landslide locations. The flat-lying nature of the bedrock combined with the lack of clear trend in jointing and fracturing probably indicates that the bedrock would be weak, according to Johnson. Note that the study area is not a highly populated area. Predicted environmental change. The potential impact of these post-glacial landslides is they will rapidly cause destruction of everything in their path. The number and size of landslides in the southeastern San Juan Mountains indicate that they have a major impact on both short-term and long-term landscape evolution, according to Johnson. Environmental change impacts of the post-glacial landslides are glaciers have retreated, which will result in the glaciers causing an oversteeping slope, which causes loose debris on glacial tills, and glaciers will disappear, which will cause an increase in landslide activity. Landslides pose considerable risk to people's livelihood and to the environment. They cause great disruption and economic losses by the destruction of infrastructure works such as roads and other communications and utility lines, and of cultural heritage and the environment, according to Sasa et al. In 2007. Among the processes that continuously modify landscapes, landsliding stands out because of its severe and long-lasting negative effects on natural and human-dominated ecosystems. The results of climate change by increasing the land surface area temperature, or LSAT, can cause the glaciers underneath the land surface to melt, which can trigger post-glacial landslides. By having an increase in temperature, it can cause an increase in the number of landslides throughout the world, thus can damage infrastructure, vegetation, people's lives, and overall the environment. The increase in temperature may cause an increase in stress on soil materials, which may result in a frequency of landslide occurring. Thank you for listening to my paper.